Hello students, welcome to Methodology classes 9396 where math meets logic. In the previous two classes of the polynomials class 10th, we studied about the geometrical meaning of the zeros of the coefficients, and in the next lecture we studied about the relationship between the coefficients and zeros of a quadratic polynomial and a cubic polynomial. In this class we are going to study about the division algorithm of two polynomials. We already have studied about the division algorithm for real numbers. So we will try to see whether the division algorithm for the polynomials will remain same as the division algorithm of real numbers, or will there be any difference. So it's going to be an interesting topic. But if you are just focused on the board examinations of the CBSE, you can leave this topic because CBSE has removed this topic from its rationalized syllabus. But I will request you to understand this topic also, because in future when you will be appearing for many competitive examinations, this topic will be there. So let's start. Now let us try to understand the division algorithm. So students, this division algorithm has been removed from the syllabus of the CBSE, but we should know these things for other competitive exams which will be facing after 10th or after 12th. So division algorithm is one of important concept and we should be aware about that. So let us try to know about the division algorithm. So students, we already know how to divide real numbers. For example, if I have to divide 25 by 4, so it will go 6 times 24 and remainder will be 1. So we know that 25 is equal to 4 into 6 plus 1. So 25 is dividend is equal to 4 is divisor times 6 is quotient plus 1 is remainder. So the same concept is valid in case of polynomials also, but in case of real number, we can compare the values of two given numbers. Like I can say that 1 is less than 4, and we know that when the number is smaller than the divisor, then we cannot divide it further, and that becomes the remainder of that problem. But there is a problem in case of the polynomials. I cannot compare the values of two given polynomials. Like I cannot say that x is less than x square or x is greater than x square. We cannot say until and unless I know the values of x. It seems that x will be less than x square or x will be greater than x square, but depending on the values of x, any of the statement can be false. So how do we reach that what is the remainder of that division of the polynomials? So to remove that difficulty, we have, in case of the polynomial, same relationship will be true. So in case of the polynomials, this comparison about the values of the divisor and the real remainder cannot be done because they are polynomials and their values depend on the value of the variables. So if there is any polynomial, suppose p of x, and we are dividing it by another polynomial g of x, and suppose the quotient is q of x, and after solving we get the remainder as r of x. So the same relationship will be true in case of polynomials also. I can write p of x will be equal to the divisor times the quotient plus remainder. And how will we know that Rx is the remainder, or how will we know that whether we will be able to divide Rx further by Gx or not? In case of the real numbers, we knew that when the value of the whatever is left is less than the value of the divisor, we cannot divide it further. But in case of the polynomials, we cannot compare the values of the two polynomials. So here we will assume that degree of Rx should be less than degree of g of x, or degree of what Rx, that is what is Rx, remainder will be less than the degree of g of x. What is g of x? G of x is the divisor. So degree of the remainder should always be less than the degree of the divisor polynomial, and remaining theorem will remain same, that dividend is equal to divisor into quotient plus remainder. Now, why should we know about division of the polynomials? Because it helps a lot in case of factorization of the higher degree polynomials. Suppose there is a 4th degree polynomial or 5th degree polynomial and I have to factorize them. So if I know 1 or 2 roots, then we will be able to easily convert that 4th or 5th degree polynomial in a quadratic or a cubic equation, about which we know how to factorize them. So let us try to understand how to divide two polynomials, and then by using that division algorithm, we will try to factorize higher degree polynomials. So let us try to understand how to divide two polynomials by taking an example. So let us divide x cube minus 3x square plus 5x minus 3 by x square minus 2. So first of all, we have to write the dividend polynomial and the divisor polynomial in their standard form. Standard form is in the order of decreasing degrees of the terms. So here they already are in the standard form, so we don't need to worry. Now I have to compare the highest degree term of the divisor and the highest degree term of the dividend, and think of a number or a variable by which multiplying to the highest degree term of the divisor becomes equal to the highest degree term of the dividend. So here highest degree term of the dividend is x cube and highest degree term of the divisor is x square. So I know by multiplying by x, x square will become x cube. So we will multiply by x, so it becomes x cube, and minus 2 times x is minus 2x. So I will write with the like term, and we have to subtract. So we know while subtracting we have to change the signs. So this will cancel out and it becomes minus 3x square and plus 5 plus 2 plus 7x minus 3. Again, highest degree term is x square, and here highest degree term is minus 3x square. So I know by multiplying minus 3 to the x square, I will be getting it. So it will be minus 3. So minus 3x square, and negative 3 times negative 2 is plus 6. So from here, this will become positive, this will become negative, so this will cancel out. So I will be getting 7x minus 9. Now the degree of 7x minus 9 is 1, because the highest degree term here, the degree of x is 1, and here divisor is a second degree, so I cannot divide it further. So we know 7x minus 9 is the remainder, because its degree is less than the degree of the divisor. So in this way we divide two polynomials. So what will be the steps? Like, first of all, we have to write the dividend and the divisor in the standard form, means in the order of decreasing order of their degrees of the terms, and then we will have to think of numbers or variables by multiplying by which the highest degree term of the divisor becomes equal to highest degree term of the dividend, and then by multiplying that thing we will subtract them, and we will do it again and again until and unless the remainder has a degree which is less than the degree of the divisor. So in this way we divide two polynomials. Now let us try one more question from exercise 2.3. We already have discussed the first part of the question number 1. Now let us take question number 1 and part 3. So the question is, we have to divide x to the power 4 minus 5x plus 6 by 2 minus x square. So we have to divide it by 2 minus x square. So we will write 2 minus x square in the standard form. So we can write it minus x square plus 2. So remember students, it was 2 minus x square. So the sign of x square was negative. So I have written negative x square. And 2 minus x square. 2 was first. So there was no sign. So if there is no sign before a number, we assume it is positive. So that is positive. So we have written the divisor and the dividend in the terms of standard form, in the terms of decreasing order of the variable. So now x to the power 4 is the highest degree of the dividend and x square, that is highest degree of the divisor. So I want x to the power 4 and with a positive sign, so it is negative, so I have to multiply by negative, and it is x square. So I need x square more to make it x to the power 4. So this is x to the power 4 and I am multiplying by negative x square, so it will be negative 2x square. So signs will change. So this will cancel out and there is no x square term in the dividend. So I will write it like this only. So 2x square minus 5x plus 6. Now negative x square is there in the divisor and we want 2x square. So I have to multiply by negative first of all to make it positive, and I need 2 and the degree is same. So I don't need to multiply by any variable. So it will be 2x square and negative 2 times negative 2, negative 2 times 2 is 4, negative 4. So I will write below the constant term and I will change the signs, so it will cancel out. So negative 5x plus 10 is the remainder, as divisor is of the second degree and this is of the first degree, so I cannot divide it more. So minus 5x plus 10 should be the remainder. So students, I hope you would have understood how to divide two polynomials. So what are the steps? First of all, we have to write the dividend and the divisor in the standard form. Standard form is in the order of decreasing degrees of the variables. And then you have to take the highest degree term of the dividend and the highest degree term of the divisor and think of a term by which multiplying the highest degree term of the divisor will give the highest degree term of the dividend. And in this way, the process will go on at each step. So I hope you would have understood how to divide two polynomials. Now let us take question number 2. So we have seen in the last two questions how to divide two polynomials. Now let us take question number 2 of exercise 2.3. So the question number 2 is, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So we have to divide the second polynomial by the first polynomial and check whether the second polynomial is a factor of the first polynomial or not. So the logic will remain same as we find out factors in case of real numbers. In real numbers also, we see if the remainder comes 0 or remainder becomes 0, we say that the divisor is a factor of the dividend, and if the remainder is not equal to 0, then we say that the divisor is not a factor of the dividend. So let us take the first part of the question number 2. So question number 2. So the first part, let me write the question. So it was 2t to the power 4 plus 3t cube minus 2t square minus 9t minus 12. So this is the dividend and we have to divide it by t square minus 3. So students, as we can see, the dividend is already in the standard form and the divisor is also in the standard form. So the highest degree term of the dividend is 2t to the power 4 and the highest degree term of the divisor is t square. So we have to think what should we multiply to t square to get 2t to the power 4. So the numerical coefficient of t square is 1 and the numerical coefficient of t to the power 4 is 2. So we should multiply 2 to 1 to get 2, and the variable is t square and t to the power 4. So we need t square more. So it will be 2t to the power 4, and if we multiply minus 3 into 2, minus 6, and let me write below the like term, so it will be easy to add and subtract. So minus 6t square. So we will change the signs. So this will cancel out. So remaining will be 3t cube, and minus 2t square plus 6t square will be minus plus 4t square, as 6 is greater than 2 and its sign is positive. So answer sign will also be positive. So it is plus 4t square. Now again the highest degree term is 3t cube and it is t square. So I need to multiply by 3t. So it will be 3t cube, and 3t minus 3 is minus 90. So minus 90 minus 12. The remaining terms of the dividend also we took it down. So I will write 3t into minus 3 is minus 90 below this. So I will change the signs. So these both will cancel out. Now it is 4t square minus 12, and it is t square. So I have to multiply by 4. So 4t square, and minus 3 into 4 is minus 12. So it will cancel out. So the remainder is 0 here. So I can say t square minus 3 is factor of 2t to the power 4 plus 3t cube minus 2t square minus 90 minus 12. So it's in this way, the process will remain same like division of the two polynomials, and if the remainder comes out to be 0, we will say that the divisor is a factor of the dividend. Now let us try one more problem to make the concepts clear. So question number 2, and let me see which option to try. So let us try part 3. So the given polynomial to which we have to divide is x to the power 5 minus 4x cube plus x square plus 3x plus 1. So this is the dividend, and the divisor is x cube minus 3x plus 1. And both the divisor and the dividend are in the standard form, so we don't need to worry. So the highest degree term of the dividend is x to the power 5, and it is x cube in the divisor. So I need to multiply by x square to get x to the power 5. So it will be x to the power 5 minus 3x cube plus x square. So we will change the signs, negative, positive and negative. So this will cancel out. This will also cancel out. And minus 4 plus 3 is minus 1x cube plus 3x plus 1 is remaining. And I can see here it is minus x cube and x cube in the divisor. So I need to multiply by negative 1. So it will be negative x cube. And negative into negative is positive 3x minus 1. So this will be positive, this will be negative, this will be positive. So this will cancel out, this will cancel out, and 1 plus 1 is 2. So in this case, the remainder is not equal to 0. So we can say that divisor is not a factor of the dividend. So we can write as remainder is not equal to 0. So divisor is not a factor of dividend. So we solved two problems. In one problem, the remainder was 0, so the divisor was a factor of the dividend, and in the second problem, remainder is not equal to 0, so the divisor is not the factor of the dividend. So this was part 3 of question number 2. Now let us try the next problem. Question number 3. Obtain all the zeros of 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. Two of its zeros are given here. So we will use, as we discussed, this is the reason why we learned dividing two polynomials, because its degree is 4 and two of its zeros are given, so I can solve it and we can convert this polynomial in a quadratic polynomial which can be factorized easily. So let us try to solve this question. So question number 3. So the given polynomial is p of x is 3x to the power 4 plus 6x cube minus 2x square minus 10x and minus 5. So this is the given polynomial, and its two of its zeros are, two zeros of this polynomial are given. Two zeros are root 5 by 3 and minus root 5 by 3. So these are the two zeros given. So root 5 by 3 and minus root 5 by 3 are its zeros. So I can write, so x minus root 5 by 3 and x plus root 5 by 3 will be factors of the polynomial. So if they are factors, so their product, that is x minus root 5 by 3 and x plus root 5 by 3 will also be factor of p of x, because they doesn't have any factor in common in between them, so their product will also be the factor of that given polynomial p of x. Now if x minus root 5 by 3 and x plus root 5 by 3, their product is a factor of p of x, so by using the formula a minus b into a plus b, I can say x square minus 5 by 3 is also a factor of that polynomial. So if I simplify it, so we can take 1 by 3 common, so it will be 3x square minus 5. So 1 by 3 times 3x square minus 5 is a factor of this polynomial. So if 1 by 3 times 3x square minus 5 is a factor, so we can say, so 3x square minus 5 is also a factor of p of x. Is also a factor of p of x. So if 3x square minus 5 is a factor, then we can divide the given polynomial by 3x square minus 5. So let us divide. So students, if 3x square minus 5 is a factor of the given polynomial, it should divide that polynomial. So let us divide the given polynomial by 3x square minus 5. So the polynomial was 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5. So this was the polynomial, and the factor by which we have to divide is 3x square minus 5. So 3x square, 3x to the power 4. So I should multiply by x square. So I will get 3x to the power 4 minus 5x square. Writing the terms below the like terms. So this will cancel out. This will become positive. So it will be 6x cube plus 3x square, and we can take minus 10x minus 5 also down. So 6x cube we want, and we have 3x square, so we have to multiply by 2x. So I'll be getting 6x cube and minus 10x. So this is negative, this is positive, so this will cancel out. They are of opposite sign and having the same magnitude. So remaining is 3x square minus 5, and divisor is also 3x square minus 5. So we can go 1 times. So it is 3x square minus 5. So the remainder is 0. So by using the dividend is equal to divisor into quotient plus remainder, I can write 3x to the power 4, the dividend, that is 6x cube minus 2x square minus 10x minus 5 is equal to the divisor 3x square minus 5 times the quotient we got x square plus 2x plus 1, x square plus 2x plus 1 plus remainder, that is 0. So we can see here 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 is equal to 3x square minus 5 times x square plus 2x plus 1. So we can write 3x square minus 5 times, and we can see this is the square of x plus 1, because when we square it, so it will be x square plus 2x plus 1. So 3x square minus 5 times x plus 1 whole square is equal to our dividend. And if I have to find out its zeros, so we can say to find the zeros, means we have to equate it to 0. So 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 will be equal to 3x square minus 5 times x plus 1 whole square is equal to 0. So I can write 3x square minus 5 is equal to 0, or x plus 1 whole square is equal to 0. It means from this we already know the zeros were given. So from this we will be getting x is equal to plus minus root over 5 by 3, or x plus 1 whole square will be 0 only if x plus 1 is equal to 0, and this implies x is equal to minus 1. So the other zeros are minus 1 and minus 1. So it is a repeated root. It means the curve of this polynomial will be touching x-axis at x is equal to minus 1. Will be touching x-axis at x is equal to minus 1. Because it is a repeated root, it is not crossing that x-axis at that point. So in this way, we factorized a 4th degree polynomial because it was 2 roots were already given. So from that, we found out a quadratic polynomial which is a factor of that polynomial, and by dividing by that quadratic polynomial, we got the divisor as another quadratic polynomial, and we factorized that divisor and we got the other 2 roots as a repeated roots, x is equal to minus 1. So this in this way we can use division of 2 polynomials to factorize a higher degree polynomial. Now let us try another problem, question number 4 of exercise 2.3. So the question number 4 is, on dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and the remainder were x minus 2 and minus 2x plus 4. So we have to find out the value of g of x. So in this question, students, you can see the divisor is not given and the quotient and the remainder are given. So we know a formula which connects the dividend, divisor, quotient and remainder, and by using that formula we will connect all the given information and we will try to find out the value of g of x. So let us try question number 4. So question number 4 is, the given polynomial is, let me write, p of x is x cube minus 3x square plus x plus 2, and the divisor it is given is g of x, quotient is given, the quotient is x minus 2, and the remainder is given minus 2x plus 4. So these all informations are given and we have to find out the value of g of x. So we have to find out g of x here. So we will use the formula dividend is equal to divisor into quotient plus remainder. So we are going to use this formula. So dividend is already given. We have to divide x cube minus 3x square plus x plus 2 is equal to divisor is given to be g of x times its quotient is x minus 2 plus remainder is minus 2x plus 4. So to find out the value of g of x, we will shift everything on the left hand side. So first of all, let's shift negative 2x plus 4 to the left hand side. So it will be x cube minus 3x square plus x plus 2. So we will shift everything on the left hand side. So shifting plus minus 2x plus 4. So it will become negative 2x plus 4 is equal to g of x times x minus 2. So here when I will open the bracket, it will be plus 2x. So I can add 2x in this. So it will be x cube minus 3x square and plus x plus 2x will become plus 3x and it will be negative 4 plus 2. Negative 2 is equal to g of x times x minus 2. Now there is a product in between g of x and x minus 2. So when I will shift x minus 2 to the left hand side, it will become in the divisor. So it will be g of x is equal to x cube minus 3x square plus 3x minus 2 divided by x minus 2. So we have to divide this polynomial by x minus 2. So we will get x cube minus 3x square plus 3x minus 2 by x minus 2. So it will go x square times, so it will be x cube minus 2x square, so negative positive. So this will cancel out and minus 3 plus 2 is minus x square plus 3x minus 2. So x is there, we want minus x square, so it will be minus x, so it will be minus x square and minus minus plus 2x. So this will be positive, this will be negative, this will cancel out. So plus 3 minus 2 is x minus 2. So it will go plus 1 times x minus 2 is equal to 0. So the value of g of x, so we can write, so g of x will be x square minus x plus 1. So this is the value of g of x. So in this way, in this question, students, a polynomial was given and its divisor was g of x, quotient and remainder was x minus 2x plus 4 was given, and it was asked to find out the value of g of x. So we used the relationship between dividend, divisor, quotient and remainder, and after that shifted everything to the left hand side, and then in the last, to find out the value of g of x, we divided the given polynomial by x minus 2 and we got the value of g of x as x square minus x plus 1. So in this way, students, we finished all the exercises and the questions and the concepts from the NCERT book. Some questions I left as a practice for you. In the next lecture, we will be starting with the NCERT exemplar and some important questions from the R.D. Sharma book and some higher level thinking questions which force you to think more. So we will meet in the next lecture with some interesting questions. Till then, take care and keep on practicing.